So today I am going to talk about today I am going to start a very fascinating topic that is known as nonlinear dynamics. So here I will briefly introduce what do we mean by nonlinear dynamics. So in nonlinear dynamics is a branch of physics in nonlinear dynamics is a branch of physics that deals with the behavior of nonlinear systems. Since we know that most of the system in the nature are nonlinear, and so first of all let me talk about that. What is a nonlinear system? It is a system in which the change of output is not proportional to change in output, change in input. And this is a very simple definition of this nonlinear system. So, nonlinear system such as in a system such as weather or neurons often appears chaotic, unpredictable, or counterintuitive. And yet their behavior is not random, and yet their behavior is not random. So these are the very brief characteristics of a nonlinear system. The study of nonlinear systems leads to new phenomenon like soliton, then chaos, and fractals. These are very interesting phenomena which are there. This is because of the study of nonlinear dynamics. So first of all, let us briefly talk about that. What is a soliton or solitary wave? A soliton or solitary wave is a self-reinforcing wave packet that maintains maintains its shape while it propagates with constant velocity. So let us take an example. And say it is a wave packet, and say it is its envelope. It is the envelope of this wave. So this envelope represented by red color, it is known as envelope soliton, right? And this green colored wave packet is known as carrier signal. This is a very simple example, right? So it is basically a hyperbolic secant means SECH envelope for wave solid. Right, so this is a brief idea about the soliton, but it is beyond the scope of this book, so I am not going into detail of it. So now let me talk about chaos. So according to Edward Lorenz, a chaos when the present determine the future, but approximate present does not approximately determine the future. Means once we know the initial conditions approximately, then we cannot determine its future exactly, because there is a lot of undeterministic nature. And chaotic behavior exists in many neural systems including fluid flow, heartbeat irregularities, weather and climate. and it also occur in stock market and road traffic also. Right. So this is a brief introduction of the chaos. Now let us talk about a very interesting topic, that is the fractals. So a fractal is a never-ending pattern. A fractal is a never-ending pattern that repeats itself at different scales This property is called self-similarity. This property is called self-similarity. Although fractals are very complex, they are made by repeating a simple process. Made by repeating a simple process. So let us understand it with the help of a example. Let us take a geometrical fractal. Let us take few triangles. And what we did, if we cut a triangle into this, then what we are getting? So if we cut this triangle, so that means we will remain with this portion. We will remain with this portion, right? We will remain with this triangle. And if we further do one thing, we will cut again more triangle. Right. So what we did, we will again cut a triangle like this, and then like this. And so on. We keep on doing this. So that means we will remain with this part. we will remain with this part, this triangle and this triangle, right? So, and if we keep on doing this, a very complex pattern will be obtained, and this is these are known as geometrical fractals, right? And this triangle is known as Sierpinski triangle, and repeatedly here what we did, we repeatedly removing the middle triangle from the prior generation. That's what we did, and we will get a very interesting. So this is all about the fractals. So in this lecture I talked about a brief introduction to nonlinear dynamics, and the consequence of it means the new phenomena which we are observing. One is the soliton, another is the chaos and fractals, right? So that's all for this lecture. In the next lecture I will talk about logistic map and the very interesting phenomena is what we call I will talk about logistic map and nonlinear growth. In the next lecture I will talk about that. That's all for today's lecture.